Welcome back. So we will talk about Boolean expression in this session, this video. Before that, I want to do an overview because why are we learning Boolean expressions? Because we need that so that we can branch. In the other assignments, you see that we use an if number of hours worked is larger than 40, then you have overtimed. So you need a Boolean expression to decide on what code to execute in some cases. And for example, in the while loop, we have to say, okay, if it looped the 10th time, then it needs to stop because I only wanted to loop so many times. So what is Boolean expression? I actually think all of you know. In the coming quiz, there are true and or false questions, and so it's basically just true or false. If an expression can be evaluated to, like here, hours worked smaller than or equal to 40, then this block of code is being executed. If not, then this block. So you need to know how to write, how to put the condition here so that you can branch. So we talked about this before, smaller than, larger than, or equal to, and then this is equal to. So I actually add a column so that you can see the equivalent math operator. So not equal is like this in math. Testing something is equal actually is like this, but we are using this as assignment operator, and that's why in a C++ program we use equal. And so you see this is a Boolean expression because it can be evaluated into true or false. 3 is smaller than y is false, right? So we won't go over it because we did already. So what if I want to express two different conditions and have them together? Like if I need that condition to be x larger than 0 and y smaller than 10. So logical operators came into rescue. I hope you have already encountered this, like and, or, and not. So basically, if a statement 1 and statement 2, to evaluate this to be true, both statement 1 and statement 2 has to be true. I think this is the easiest way to remember it. So true and true will become true. True and false, false and true, false and false will all become false. So example, you can see, you can write an expression like this with and, meaning and in logic. Or operator is less strict. So and is very strict, right? Only one case it can be true. But in or operator, it's actually pretty relaxed. There's only one case that will be false. When is it? Which is when statement 1 and statement 2 both are not true, both are false. So so it means that when statement 1 and statement 2 are true, this is true or false, false and or true. All these cases are true. If you don't know what I'm talking about, write it down, think about it, and remember it. And in the textbook, I think there is a chart also you can study. So for example, we can use it to express two, combine two different statements and use a or in between them to express this case. Not operator, so it's basically the opposite. Not true is false, not false is true. So this is a case that we need to talk about because we actually cannot use the two operators continuously like this in a C++ program. So to express this, you actually have to break it down into two parts. And because x has to be between the two numbers, so we would use and to chain them together. So since every Boolean expression can be evaluated into true or false, and so true, we have a Boolean data type, which is helpful to when we think about, basically we are putting a blue Boolean basically in the condition for the loops, and if else and other branching statements. It actually depends on which statement. So for if else, it actually is worked that way. So how do you declare a Boolean data type? It's just like int, right? Int x equals to 1. Now blue, did I ate an apple, equals to false or equals to true. Of course it and then it actually can be expressed numerically. Any number besides 0 will be evaluated as true, and then any number will be false. But I try to not use it unless there's a reason to. Always, try to use it the way it's supposed to. When you are more advanced, you can do it this way. For some, actually, there are some cases that it would be nice to actually understand this. But for now, put it in the back of your mind. When you need to use it, you can always read documentations. So, again, very important for the order of precedence, because when you add the and or not, if you don't write the statement very clearly, you would not want to know. You would want to know the order of precedence. But honestly, always use parentheses. Always make it clear. Don't depend on the order of precedence when you are trying to write your program. I highly not recommend it. So this is what I recommend to avoid. Not to use not. Basically, don't use not when you can. Don't depend on the order of precedence, but make it clear using parentheses. Write very clear expressions. Try to not use the integers to express Boolean. Try to not use the short circuit evaluation. I know it talked about they talk about it in the book. It's basically how C++ using lazy evaluation, because once it evaluates something, the first part, if it doesn't. Anyways, maybe I will not talk about it actually, because I don't want you to use it. So write good expressions, because like I said, 2 months later you read the code, you have no idea what happened, and you are depending on order of precedence, and then you forgot the rules already, kind of. Then you have to if you have to debug or something, it's going to be you can do whatever you want actually, but I'm trying to save you time. But if you want to play with it and spend time learning it, it's fine too. So I want to practice with some examples so that we get this. Yeah, I hope all of you get this, because it's really important you understand this so that you can move forward with the branching and the loops. So in this example, x equals to 0, y equals to 10. So what will the first expression evaluated to? X is equals to 0, so this first part, statement 1, will be true. And then statement 2 actually will be false, because y is 10, which is smaller than 20. And so true and false will equals to false. So this is true, this is false, but true or false actually is true. So now 0 is 0 smaller than 5. Yes, it is. So this is true. Not true becomes false. 99. Well, it's a number which is not 0, so it means it's true. Not true is false. And then 0 plus 1 equals to 1. 1 is not bigger than 2, so this is false. What about this side? 10 minus 2 is 8. 8 is not bigger than 10, so it's false again. So, like I said, you can pause your video, try to understand it, I guess. The concepts that we covered in this video: Boolean expressions, logical operators, and Boolean data type. See you soon.